Okay, so today we're working on 1.5, Solving Inequalities. Inequalities can be graphed on a number line. These are inequalities with only one variable. The graph helps you visualize the values that make the inequality true. If it doesn't include the point, we use an open circle. That means there's no extra lines underneath. It's just greater than, less than, or not equal. If it does include the point, we use the closed circle. A way one of my students has told me to remember this is if there's extra ink down here, there should be extra ink in here. So no ink, no ink. Ink, ink. Okay? So let's look at some examples. We have x is greater than 4. Because it's just greater than, we use the open circle. And then we look to include the numbers that are greater than 4. So you say, okay, there's 4. Which is greater than 4? Is it 5 or 3? Well, 5 is greater than 4. So we would include those numbers. We'd put the arrow over it. For x is greater than or equal to 4, it's the same line except with a closed circle because we have the equal sign, the point is included, extra ink, extra ink. Okay, then we have x is less than 4. Well, it doesn't include the equals, so it doesn't include the point. It's an open circle. And 3 is less than 4. 5 is not. So our arrow covers the numbers that are less than 4. For x is less than or equal to 4, it's the same line. We just have to have a closed circle there because the point is included. Okay, now writing an inequality from a sentence. So 5 fewer than a number is at least 12. So we know that 5 fewer than a number is n minus 5. And it's 12. And then we have to figure out this at least portion. If I say you have to spend at least 20 minutes reading a book tonight, I don't mean you can spend 19 minutes. I mean you can spend 20 minutes. You could also spend 30 minutes. So it's going to be greater than or equal to. The quotient of a number and 3 is no more than 15. So we have the quotient of a number and 3, and we have 15. And then we have to figure out this no more than. So let's put it into a situation that we might encounter in real life. Say you have to go pick up some milk on the way home from school. And your mother has handed you the charge card and a list of things besides milk she needs. And she tells you that you can spend no more than $15. So if she's telling you no more than, that means you might be able to sneak in a Twix bar if your total comes to, say, $13. But if you sneak in a Twix bar and it comes to $18, you know that things are going to be not so great when you get home because you have gone over. So no more than 15 or the electricity bill will bounce. So that means you want to go less than or equal to. So when you multiply or divide each side of an inequality by a negative number, the direction of the inequality is reversed. This is super duper important. I mean, like, really important. When you multiply or divide each side of an inequality by a negative number, the direction of the inequality is reversed. That means you flip the sign. That's super duper important. Highlight, star, do something with it. Okay, so let's do some extra problems. We have solve negative 2x is greater than or equal to 6. So first thing we're going to do is get that negative 2 away from the x because we want the x all by itself. Okay, so we end up with x on this side and negative 3 on this side, but, we've divided by a negative. So what do we have to do? We have to flip the sign. So we're going to end up with x is less than or equal to -3. So now let's graph this thing. First thing we're going to do is find -3. There it is. And then we have to say which numbers are less than -3. It also should be noted that we have a closed circle because if we are including the point with the equal sign. So which numbers are less than -3? Is -4 less than -3? Or is -2 less than -3? This one gets a little challenging. So I like to think of money in the bank. If you have -4 in the bank, is that less than having -2 in the bank? Yes, -4 is less, so we draw our arrow this way. Okay. Next, we have 9z plus 2 is less than 4z plus 15. So we need all our z's on one side and our numbers on the other. So let's get rid of our numbers first. We're going to take that little that 2 and subtract it off both sides. This one will cancel. So we get 9z equals 4z, and 15 minus 2 is 13. So now we have to get rid of this 4z. So we subtract 4z from both sides. And we end up with 5z is less than 13. So far, so good. But then we divide by 5 to get that z all by itself. And we get z is less than 13/5. And I know you could say it's 2.6. However, we're going to leave it as a fraction because Math Excel generally prefers fractions. Once again, pay attention to that little blue writing next to the answer box. So, how do we graph 13/5? Well, 13/5 is roughly 2 3/5. It's not roughly. It is 2 3/5 because 5 goes into 13 2 times with 3 left over. So, is it an open circle or a closed circle? It's an open circle. And we're going to put it right about there, about 3/5 of the way. It's a little bit past half. And which way is our arrow going to go? We want something less than that. Is 2 less than 2 3/5, or is 3 less than 2 3/5? 2 is. So our arrow goes in that direction. All right. Okay, a compound inequality consists of two inequalities joined by the word and or the word or. Compound inequalities involving the word and are called conjunctions, and it's the intersection, the graph of a compound inequality containing and. Solving an and compound inequality. Solve 13 is less than 2x plus 7 less than or equal to 17. Graph on a number line. So let's look at this. We have 13 is less than 2x plus 7. And we also have 2x plus 7 is less than or equal to 17. It's two separate inequalities that we've joined together because 2x plus 7 is greater than 13 and less than or equal to 17. So let's split them apart and put the and right there. So the purple inequality, 13 minus 2x plus 7, we want to get that x by itself, so we subtract 7 from both sides. We get 6 is less than 2x. Then we divide by 2. And we get 3 is less than x. So it's an open circle, and the arrow goes to the numbers where x is greater than 3. Then, the lime-colored inequality, where we have 2x plus 7, is less than or equal to 17. We're again trying to get that x by itself, so we're going to subtract some 7s. We get 2x is less than or equal to 10. Then we need to get rid of the 2, so we divide by 2, and we get x is less than or equal to 5. So because there's the equal sign here, we're going to have a closed circle on 5, and we're going to find the numbers less than or equal to 5. So that's the way the arrow goes. Now, if you remember on the last slide, I said that this is an intersection. Oh, it says it right here. It's an intersection, so we're looking for the overlap of the two lines, which is right here. So this is actually all you have to graph, this little baby bottom part where they overlap. There's our statement. We're looking at the numbers that are greater than 3 and less than or equal to 5, which we have an x here and an x here, and our inequalities are pointing in the same direction. So we just can lump them together like that. There's your final answer. Compound inequalities involving the word or are called disjunctions. And the graph is the union. And if you remember from Venn diagrams, those circle diagrams, it means the whole thing. So anything that's graphed is going to be part of the or compound inequality. So here's our example problem. Solve y minus 2 is greater than negative 3, or y plus 4, because it's or, y plus 4 is less than or equal to negative 3. So once again, we have two separate inequalities. So let's solve the first one. We want to add 2 to both sides. We get y is greater than negative 1, and now we have to graph that. There's no extra ink, so we're going to use an open circle. And we're looking for the numbers that are greater than negative 1, things like 0, 1, 2, and so on. Now let's work on the other inequality, the purple inequality. Y plus 4 is less than or equal to negative 3. Let's subtract the 4. We get y is less than or equal to negative 7. That extra ink means we need some extra ink, and we're going to fill in the circle right here. And it's going to be everything that's smaller than negative 7. Now, this is an or inequality, so it could be in this graph, or it could be in this one. So we'll graph both graphs on the same line. And we get y is greater than negative 1, or y is less than or equal to negative 7. You cannot hook and or together. And that's the end of this video. Have a great rest of the day.